check.
I think that's it.
All right, cool.
All right, thanks everybody for coming. This is Santa Barbara JavaScript. We meet on the first Monday of every month. We have a few sponsors in town. In Boca, who's hosting us today, Space and Pizza. And also Work Zones is our main spot. If we can't find another company in town, we usually end up at Work Zones. And we've got Pay Junction and Procore hosts us a lot. So yeah, thanks very much. And I'm looking forward to hearing about Category 3, which I know very little about. But this is James Dabbs, and let's take it from there.
Cool.
Thank you very much.
Hey everybody, thanks for coming out. Folks in the back, how are y'all doing? Can y'all sort of see stuff? My intention is to keep this pretty loose and chatty, so if y'all have questions, please interrupt me. If anything is confusing, you can't see anything, like do stop me. I'm James. Hey y'all. I work for Procore. It's my side. If you'd like to come work with me, let me know. I don't do a ton of JavaScript, so if anything silly, disclaimed. Yeah, let's talk about some category theory stuff. Out of curiosity, who here is considers themselves familiar with category theory? Daniel, you can raise your hand. Come on. We went to grad school together. I know this. Okay, cool. So this is, I think, mostly a pretty intended to be an accessible introduction. I'm going to go over some details, but my hope is to kind of give you a feel for the spirit of the thing. Please don't make me say something like technically incorrect. The title here, in case that's going to be real. Okay. The title here, in case you're not familiar with the reference, is this classic book, Categories for the Working Mathematician. Again, to be kind of an accessible introduction to category theory. We'll get there. Before we start talking about that, though, I want to talk about design patterns for a little bit. Who here has heard of design patterns, sort of familiar with the concept? Does anyone want a hazard definition, introduction? Like, what's this thing about? What's it?
Oh, design patterns?
Yeah, you want to try a definition?
It's how you structure your programs. It's different ways to solve common problems.
Yeah, no, that's great. So yeah, I would say something fairly similar. I would say design pattern is sort of a prepackaged solution to a problem. It's a little bit hard to make this precise. I don't mean like some library you can go grab and reuse. I mean kind of like prepackaged solutions to shapes of problems, like consistent patterns that you see pop up. And I think one of the really important things about design patterns is that it gives you a kind of shared language for talking about and understanding solutions, right? Like you may have heard the terms presenter and strategy and visitor, right? If you need something to you see in the code, it has this such and such presenter. You have an expectation about what it does. You can kind of look past the extraneous details and see the essence of the thing. I think a lot of people's familiarity comes with design patterns comes from this classic book. If you can't see that too well, that's Design Patterns, Elements of Reusable Object-Oriented Software, from the book. And while it is a book about kind of object-oriented programming, even in that book, it does mention to favor object composition over class invariance, which is what we may have heard. I'm not going to talk too much about it, but I do want to dig into that word composition today. So composition, hazard is the definition of composition. I had to scroll up these.
Well, it's when you can take two things and invoke them together so that they create a third thing.
Yeah. I think that's pretty good. So my definition was as follows. Composition is building up large complex systems by assembling smaller and simpler ones, right? I think this is kind of the fundamental activity that we do as programmers, right? At the end of the day, the small problems are pretty easy, right? Like maybe you might need some clever algorithm or something, but usually if you break something down to a small enough piece, you can solve it in isolation. And the hard part is how do you manage putting a million different solutions to a million different people's problems together in a way you maintain some amount of standing, right? So our goal here for this talk is to try to better understand how things can be composed a little bit and to try to learn a shared language for describing patterns of composition. Right? That's kind of that's what I hope we get out of this today. Which takes us back to this topic, the idea of categories. So category theory. Would anyone like to have a definition of category theory? What's that all about? Why do we care? Why are you all here?
We don't know.
Okay, that's perfectly fair.
I think it's something that a lot of people talk about, but nobody hardly anybody can actually explain what it is.
That's fair. It is a notoriously abstract topic, so which makes it somewhat inaccessible sometimes. But I will say, like as programmers, we deal in abstractions all the time. So I hope to relate this to stuff that y'all might be a little bit more familiar with. Let me try some analogies. Anybody want to define algebra? We're going to stop with these definitions eventually, I promise. But would anyone like to hazard a definition for algebra? What's algebra all about? Set of rules? Yeah. I'd say like most branches of math are probably set of rules. It's a set of rules about a kind of particular domain. Like what is the domain of algebra? When you're talking about algebra, what are you talking about?
I think variables, like
Variables is a relevant thing. I think to me, I think the essential things about algebra are the operations that it allows, right? Kind of manipulations that you can perform. And so kind of, this is reductive, but you can think of algebra as the study of plus and times, right? If you have addition, if you have multiplication, if they behave by the rules that you're familiar with for addition and multiplication, they distribute or whatever, what can you say, right? Just like what is the total space of things you can prove? Somewhat similarly, I'd say like geometry is kind of what you say about angles and distances, or if those are primitives, like what proofs can you make? What are the relationships between these concepts? Somewhat similarly, category theory is a branch of math that talks about kind of rules about a domain. And category theory really is the study of functions and composition, right? In the same way that like plus and times are primitive notions of algebra, functions and composition are like the primitive notions that category theory talks about. Categories, I have to give a definition of category. I'm going to try to do the formal math speak here pretty soon, so just stick with me. But to give you some definition here, a category, when we talk about that, a category is a collection of objects. I don't mean object-oriented objects, I just mean things. A collection of functions between those objects, which also doesn't really mean functions like you think about it, but still think as your intuition can control that. And importantly, a category has a way of composing functions together, right? So when I say a category, I really mean some specific notion of what it means to compose. There are a few rules about how these things have to work in the same way that like addition should be commutative, doesn't matter what order you add things in, like function composition should work like you're used to. And that means basically there has to be an identity function. Subject to the thing you expect, right? If you take a function f and you compose it in a different function, you get back the original function. Doesn't matter which order you compose it in, you always get back the original function. The other kind of important rule about composition is it must be associative, which is a way of saying that if you compose f with what you get by composing g and h, that's the same as if you kind of do it in the other order. That's really just kind of a fancy way of saying that you can just say compose f and g and h. You don't have to worry about how you're putting parentheses, right? Just that kind of 3, 4, 5, 6 functions composed in a row makes sense. That's pretty abstract. Let's try to get that a little bit more concrete. Some examples of categories. The sort of classic canonical and not terribly illuminating example is sets. So you can think of the objects as being mathematical sets, functions as being sets or functions between them, and composition being your standard function composition. If you're not a mathematician, this doesn't sound inspiring to you at all, so I'm going to move on. The one we're kind of interested in today is we're interested in a category formed by JavaScript functions, right? So you can take as your object JavaScript types, permit me to say that if you will. Your functions in this category are JavaScript functions if I use the thinking of them. And composition is defined this way. If you have two functions, f and g, the composed product of those is the function that takes next, feeds it through the g, and then feeds it after f. Right? This is like if you've done much read up style stuff, if you've written like the compose function from any of those libraries, this is exactly that. Since composition is associative, right? You can compose in any order. It makes sense to write this helper function that you may have seen in some JavaScript libraries. I can compose a whole bunch of functions, and what I do is kind of step over them one at a time, and right to left, first one, the one on the far right, and then the next one, and then the next one.
I have a question here.
Yeah.
You made a point about saying the functional composition. If you go to the previous slide, I think it illustrates my question better. Okay, so I get this. You take the value of x, you apply g to it, you get some other value, and then you apply f to it, and that's your result. If if it's associative, then it's a little, actually, I think I confused between that and commutative. So, because you couldn't swap the operator and expect it to work.
Correct.
So
function composition need not be commutative.
yeah, right. Okay. I was more confused. Sorry.
Totally right. Yeah.
That help? Was that helpful?
Yeah. If the word commutative means anything to you, then take that. Yeah, the order that you compose functions in is important. Saying that that composition is associative means if you've got 3 functions in a row, it doesn't matter if you think of kind of smushing the first 2 together or smushing the last 2 together, you get the same thing. That's not a hugely important distinction, so please don't get hung up on that one if it's a little technical, but that's totally fine, you'll be fine. The main thing is, hopefully you may have seen this kind of compose helper in some like Redux library sorts of things. The idea is you can take a list of functions and compose them one after another. Right? It's kind of pipelining the operator. You feed the value into the first function, then the next one, the next one, the next one, and you get a well-defined result from that process.
We write a function in terms of other functions.
Mm-hmm.
So.
Mm-hmm. Okay. We won't do too much in the abstract here before digging into some code examples, but I want to take one more example. I want to try to illustrate that while a category has to have a notion of composition, it may not be literal plug the functions one into another like you might expect. So let's consider sort of a modified category where a function here takes in a thing of type A and returns a list of things of type B. I posit to you that you can make this a well-defined category. And what I mean by that is you can define a reasonable way of composing functions with that shape together. So to make this precise, right? If you have 2 different functions in this category, that's an f that takes in a's and gives you back a list of b's, and another function g that takes a single b and gives you back a list of c's. And you have to figure out a way to wire these together, right? You can't just plug them up one after the other because G doesn't take lists of B's, it takes a single B. There is sort of like one and only one obvious way, or obvious. There's only one way to wire these up that really kind of works. Anyone want to take a swing at how I could try to smash F and G together? Mapped is reasonable, right? If I mapped if I applied F and then mapped G over the output, I would get a list of lists of C, which is really close to a list of C, right? If I compose them together, I would want to end up with a list of C. That's pretty close. And I can kind of take that home by flattening the result. Alternatively, I can write it, I posit that I can write it this way. In this category, the way that I compose an F in a G is by taking the function that takes a single A, applies F to it, and then flat maps G over that result. Flat map is map and then flatten equivalently. So if you are interested in such things, you are welcome to check that satisfies the rules. There is an identity. It is associative. It's associative because you can kind of nest 2 and then flatten versus nest, flatten, nest, flatten. Like the ordering of those doesn't matter. It's the rough intuition. But the main takeaway here is that composition can look a little weird, but that's okay, as long as you know, for whatever your structure that you're piecing together is, you have some sane way of composing, of sequencing them. We'll dig into that a little more, but that's kind of.
Could I ask a question about that?
Mm-hmm.
So let me explain it back so if I understand.
Yeah.
Well, we've got 2 functions which are basically compositionally incompatible in that the results from one function can't be plugged into the next function.
Yep.
So we add, I'm going to call it technical word, a shim function, which transfers the output of one thing into something that's compatible with the other thing.
Yeah.
And it looks like,
sorry,
I'm not sure what flat map does, but it looks like it takes a list and turns it into something else.
So flat map is the same as map, and then followed by a flattening. So if you map G over this list, you end up with a list of lists. So this then just kind of flattens that down to just a single list. So it removes the next. But yeah, totally. The core idea here is we have 2 functions that don't really plug together directly, not the way you want, but they're close, right? I ought to be able to do this is the intuition. So yeah, we have some other ingredient, some binding function, right? Like some strategy for piecing together in a way that makes them fit, right? So such that this compose function takes in an A and returns a list of C's. That's the motivation.
The crucial thing that I might add is that this shim function, as you put it, that's a good intuition. But sometimes you have a shim that kind of like branches and depends on the stuff that you're plugging in. And here, we have to be able to find one shim that works no matter what the shape of A, B, and C are.
It seems like a tall order.
Yeah, but for arrays, we can do it.
Well, the thing is that the way it's been presented here is kind of a black box, which kind of just solves the problem, which doesn't provide all the input that I would like. So I would have felt more comfortable with defining another function, let's call it map or shim or whatever, which takes a list and turns it into something else that F could then accept. And I think that's what's been done here. It's just that I think I couldn't really follow the detail.
Okay, cool. This is like motivating overview. We're gonna work through this with like a concrete example with some code. So let's try that out, and then if you still have a question, let's come back to it with some more specifics on it. Is that right?
Sure. By the way, when I look at category, I always come up with these same kinds of questions. It seems to me there's a lot of hand-waving jargon inserted in key spots to make it look simple, when in fact, it just makes it look more opaque. Well, that's my personal preference.
Totally good.
Right? But I mean, so it's kind of like part of the JavaScript lore now, right? Yeah. No.
Oh, that's
Yeah, so like that is a fairly standard function. It's in like Lodash, for instance.
I think it's now it's now in the
Cool.
standard library.
Good job carving out though. A lot of people probably feel that way, so it's good that you just do like, hey, what's confusing looks okay. Like I think that's I don't know.
But I think really an observation related to the proponents of category theory in general.
Yeah.
That's just my prejudice.
Yeah, totally get that. We'll have some room for that discussion at the end. Cool. Any other questions before we move on? We'll circle back, I promise. We'll wait to that. Okay, so again, we're going to look at this idea of composition. Why do I care? Why do I care about things being composable? I think the general motivation, I want my programs to fit nicely. You may have seen patterns where you end up writing these actual literal compose operators. You may also see some analysis to pick here is exactly like compose, except it uses the other way, right? It's a pipeline, like the pipe operator in Elixir or something. The idea is, for both of them, right, you want some way of saying, I want to take a single value and feed it through this pipeline of functions. It turns out it's a pretty nice way to express some problems. Let's take as a given that we have these handful of relatively trivial functions. Get fetches the key out of an object, uppercase, does what it says. Take takes the initial slice of the string, things like that, reverses. So assuming we have these named functions, if you have something like a product operator, you can write something that looks like this. I think even if you haven't seen JavaScript before, you understand the intent of this code. There's some things that I like about it. I think it's clear here to see what I want to do, and importantly makes it like there is no branching, there's no conditional, it's always the same consistent data flow. I take my value, I fetch the name, I update it, I take the first 6 characters every time. One of the nice things about this perspective is you could even write that this way and think of the pipeline itself as a fundamental object, right? Like the pipeline is the process that feeds a value through the sequence. And then I can build up that pipeline in some place and then apply that pipeline to data later, right? Just thinking about the data flow. This is higher level, right? It's not as immediate to see literally what the computer is doing, but I think it declares your intent at a high level. And the reason it works is because these functions fit together very nicely, right? Like my getName function takes an object and returns a string, uppercase takes a string, returns a string, and on and on and on. So I can feed the output of one to the output of the next.
And when you've got a bunch of these things stacked up and it doesn't work, how do you know which one was the one that broke the type chain?
I'll get to that. Thank you for the leading question. Yeah.
Just run on that right now.
Yeah. So the pipe operator here takes a list of functions, and sequences them one after the other. In this case, starting with the first one, flowing through the rest. Yep. And as long as they fit together, that's great. That works perfectly well. I will say just a parenthetical, instead of writing get name is a function, I normally think of that as like get is a function that takes a string and returns a function that takes an object and returns. So you may see some of this notation here in a bit. But that aside, right, the whole thing fits together nicely, and that's what makes it work. But that is really kind of unrealistic. Like I'd like to think of that. Like, yeah.
Sorry.
No.
Clarification for pipe method. Is that something built in JavaScript here, or is something hypothetical we're doing?
It is provided by many libraries, but if it is not provided to you, you can write it in this. Again, I know it's a little opaque if you're not used to the style, but the idea is you take a single value and you feed it through the functions in the pipeline one at a time. Take the output one and feed it to the next.
So it's interpreted at, so all the functions are actually interpreted at definition time, right? In this case, it's not like whenever you trigger it, then all the function gets read. It's actually, they get read as you're composing.
Depends on how good your compiler is.
Yeah, because I was thinking about this because I was working with the ArcGIS, and then I think that one is like you won't get interpreted until you trigger the pipe itself. Then all the function gets read. So I was just wondering, like.
Yeah, I guess that, like there are some environments where your libraries can do some fancy fusion things and save you some stuff up front. I'm not talking about this as a performance consideration at all. It's purely sort of like a specificity concern. It's going to vary some. Happy to look at specific afterwards. That would be helpful.
So how does this spread layer work? So it just say takes the if you can go to the current slide.
Sorry, it's real slow. Okay, there you go.
Is there a spread of
Yeah, so the question is this syntax here. So your pipe is a function that takes an arbitrary number of arguments, and fs will be the array of all the arguments, which I expect it to be functions that you kind of plot at the time. The question. Okay, so this is all good for a relatively contrived example of just like formatting a whole bunch of strings. For this framework to be of any value at all, you should be able to kind of scale it up and use it for more complicated setups. Like I'd like to think about things like this. I do more backend programming, so forgive me. The example, but I'd like to think of like a controller, right? A handler for a request to a server, to be built up of a pipeline of first validating the user input, and then taking the validated data and performing some action, talks to a database or nodes, and then taking the result of that action and presenting it to the end user as HTML or JSON. Right? I want to split out that pipeline into various pieces. And I want to do that part so I can like break the pieces apart and test them individually. Right? Validate is a pure function that I should be able to just feed in other content and see how it works. I shouldn't need a database connection to do that. I might for perform. I shouldn't for present. But unfortunately, this doesn't really work because things can go wrong, right? Like validate is a pure function. I can feed it in data, but the problem is it might error, right? Like sometimes there are validation failures and sometimes there aren't. I need to handle those differently somehow. Like perform is a reasonable enough function, but it needs some connection to a database that isn't really always present or like obvious. It's going to need to like it has some side effects and change the world somehow. Present as a relatively nice pure function. I need some way of wiring them all up together. I still want to think of it as a pipeline, but they don't plug up end to end. We're going to take for our topic of discussion today a relatively simpler, like lower level example. And the problem here, like the motivation is I want like a command line thing that a user can use to request a password reset for some service. Yeah.
This is very slightly off topic. Are these examples all legal JavaScript, or are they just made up and are they legal JavaScript? Could these actually be tested on my machine?
I believe they are, although I am not entirely confident on
anyway,
yeah, I'm not entirely confident on like what
that's good.
ES version would be for which pieces of it.
But, you might have just been conjuring them up as examples to illustrate the abstract point, or you might have been using them JavaScript example. But anyway, it's very valuable to me to know that actually this is JavaScript syntax, and at least hopefully the intent is that we can compile them. Yeah.
Definitely, and we'll look at the actual code here. But this is definitely one that we are concretely trying to get to work, right? I would like to build up a send password reset function. I want to think of it as a pipeline where I do a couple things. I prompt the user for their email. I know that reads a lot. Given whatever they respond back from the prompt, I want to find a user out of my database or something. Given the user that I found, I want to generate a password reset token for that user. And given the reset token, I want to send that out as an email, right? It would be nice if I could think of it that simply. And kind of in writing this, I'm picturing something like that. I'm picturing the prompt as a function that takes a string to prompt the user for and gives me back an email address. And I can take that and get a user. I can take that and generate a reset token. I can take that token and send an email. But the problem is, in the real world, things can go wrong constantly, and we really do have to worry about that, right? So in the real world, they're not so nice. We want some strategy for, even though they don't compose so nicely, of kind of pushing them together and making them work in their pipeline anyways. So that's what we're going to do. We're going to do a lot. Any questions about it? Cool. Yeah.
Okay, so you have string to email address, and then email address to user, and then user to reset token, then reset token to email. So it looks like superficially they all compose. I feel like you'd be more explicit about why they don't.
Sure, yeah. I don't have the syntax to write it in a neat, compact way, but yeah, so some things that I expect to go wrong. When I prompt the user for their email address, they might, for instance, control C out, I might get an empty string back or something, right? I might not even have the email address to look up. I want to handle that over something. Given email address, I may or may not have a user that matches any companies. I have an inequality that I can't find or something.
So these signatures that you wrote, they're kind of like lying a little bit.
They're lying.
Okay.
Yeah.
Thank you.
Yeah. Like, were it not for those sorts of failure modes, this would work.
Okay.
But in real world, like, all of our functions do I/O all the time, talk to database all the time, and kind of network feed down, mouth user data, like they can fail in any rate of those. Yeah, absolutely.
So you only want to keep going if everyone succeeds. If you fail, you want to break up.
Thank you. Yeah, so what I would like to do is I'd like to end up with some pipeline where if an earlier step fails, I don't attempt the later steps, right? Stop there, there's no point going on. I would also like to end up with some sort of description of what failed. I want to be able to recover, right? Was it because there was an email address? Why, right? Some back. You could be much more specific than that, but my intention here is to recover that error as just a straight description. You could make it be a more complicated object with a whole bunch of metadata, but we'll just constrain for now to see how it goes. Yeah.
Curious, like, do people actually for this just pass like a string down, like an error message, like optional parameter? How does it actually do it? So
I feel like it's more normal to have some sort of data type that represents all of the error kinds that you expect somehow and gives each a little bit more structure, right? Like if it's a validation failure, you might want to record what field or fields failed. Maybe that's like an object that says field name to list of error messages. It could be pretty complicated depending on how much of the structure of the errors you want to capture. But like, lowest common denominator here is just a string message.
It sounds like usually when you take a problem, you think in terms of the return time, the guy's email address, for example, and then we go on fine. And it sounds like to address the more unanticipated or the other possibilities that might occur, you're enriching the type, replacing it with a certain kind of variable, which would basically say, result is okay, here's the number. Or the result failed because the guy didn't include any data, or because it didn't include a robot, an @ sign. So the problem with composing these things, now we can't really do it because the types, the response we get is much more complex than just a string.
Right.
So then we have to kind of make our types more elaborate to capture the true result.
Yep.
And then, of course, it's not that obvious that they're not composing it, but I guess That's why we need to be.
We want 256 types enough to capture both success or failure. But we don't want to have to go through a whole bunch of ceremony and nonsense and destructuring to have to like constantly thread through, oh, but if there was an error, do this. If there wasn't, do that. If you've done Go programming, you have to like check the results of every single call all the time. It gets a little tedious. I haven't done Go, so if I'm wrong on that, yell at me later. That's my sense. Yeah, so our goal is to enrich these types to capture that, and hopefully in a relatively ergonomic way. Okay, let's see it. So my goal here, I've got some initial code that implements this. It's sort of stubbed out there. I'm importing some fake functions. I don't actually have a database wired up. These are just kind of nonsense. I'll indignant it.
Thank you.
Sorry, delay. Is that sufficiently indignant people in the back?
It barely.
Yeah.
Yeah. Do that'll work.
That's probably, I'm going to need about that much context on screen for a lot of it. So let's go with that and see how it goes. So I'll point out that I have some relatively simplistic implementations of those functions. Let's start off with sort of the top level one. Here's my current send password reset function. Does anybody know how to hide the sidebar? Let's go. No, like not the, yeah, the actual like icons. I know it's.
Is there like a Zen mode? Very potentially named.
Shift enter.
Command palette and then Zen mode.
Oh, yeah.
Nice.
Oh.
Yeah, look at that.
But now you get to, okay, there we go.
Oh, all right. Good enough.
Is this actually TypeScript or JavaScript?
Yeah, so this is TypeScript. How familiar are people with TypeScript? Okay, not an expert. Most of my typing stuff comes from other languages. I'm trying to write that out here to be a little explicit. I hope that we don't get too much on the syntax here, but just like super quick overview for folks that aren't familiar. The way TypeScript works is you just, whenever you declare a variable, you do a colon and type of it. So the way to read this is I have my send password reset functions. Works perfectly fine. Like I have code like production. All right. But this send password reset function takes a string with a message. It's the thing we're prompting the user to respond to. And it returns an envelope or undefined. The reason it's or undefined currently is because I do the thing I said, right, where we prompt the message, we get an identity back. We're not currently handling the case of if the thing the user typed was empty. We try to find the user. We may not find the user. If we don't, we bail, in which case the function will return undefined.
So envelope is like the happy path.
Envelope is happy path, yeah. If we have the user, we generate a token for that user, and we deliver a reset email, and the envelope is the receipt of that. Okay. It's not super important, but like it has an ID, like a timestamp of when the email got sent and the contents of the email, and something like that. This is a type that I defined. So this is the individual function. It is sort of a pipeline, but there's a lot of noise in here about like control stuff, and I'd like to winnow that away and be a little more consistent about it. But it does, in a way, pipeline, prompting the user, prompting for identity, finding the user by the identity, generating the token, and delivering email for that. Here's kind of what the pieces look like. Prompt for console.log, and then uses a helper function that actually isn't hard up. Okay. So prompt for takes a string, like, hey, user, input your email, and returns a string, something like James Pro. Find user is a function that takes that user identity, that string, and looks up the user. So there you have to allow the possibility that we don't find a user. Right, so the return type here is user ID. That's got a like ID in an email, or it's and here's the implementation. It's bad. Do not use this. But it loops through all of the users in the database and just checks and returns the user if one matches. If you get all the way to the end and find the user, no user, so it returns undefined. Generate reset tokens is a dummy. Like the token is a UUID and user. We save it to the database. So generate token takes in a user and returns a token. I am at the moment not terribly concerned about that failing. I probably should be, right? Anytime you talk to a database, it could fail. But I'm going to pretend that that's not the case for this one. For now, And then deliver reset token takes that reset token and I send it to the user. So it's going to do some like side effectful deliver email to some external service and return an envelope that has kind of like the delivery information about that message. All right. So our goal is using some category theory stuff to rewrite the send password reset in something like a pipeline. I'm going to do that. We're going to start with a little bit of TypeScript nonsense, so bear with me here if you have not seen this. Just got a separate copy here that I'm going to use as like scratch space. A little bit of like editor ergonomics things. If I try to do something where the types don't match, my editor should tell me about it pretty quickly. So this, I changed this and said that I always return an envelope. And my editor is now complaining, like, hey, you failed with no envelope, but you said I'll always have an envelope. You have to fix this now. I really love something that forces me to fix all of the errors in a similar fashion. So let me restore that. Okay. So the idea here is, just like I said, we want to build a somewhat more sophisticated data type that is capable of capturing both success and failure and passing them through appropriately. The idea is to define a type either. This is a generic type, so you read that as an either A or a B. And this looks like some nonsense, and we're going to peel it away. The notion is that an either type represents, in the same way that like, you have either or undefined, an either is either a left thing or a right thing. I'm sorry about the names, I didn't make it up there. Fair standard. Otherwise, I'm trying to use something descriptive. But the very common convention is to find a type called either instead of left and right, and to use that left A type to represent the error path, and to use the right B type to represent kind of the happy path. So rather than our functions kind of return these like inconsistent types, we're going to update this to always return an either type. And kind of use that consistently.
Right. Where does type came from?
I haven't defined it yet, so I haven't defined it right. I owe you that before any of this is going to make any kind of sense. So let's do that. So the idea of left type. I'm sorry, I know these type things don't feel terribly helpful at the moment. So the idea is I'm going to have a left and a right, and they're going to look pretty similar. They both graph a value. On the left, the value that graphs is an A, and on the right, the value that graphs is a B. So I'm going to construct them differently. Left, I'm going to have to initialize with an A, and it'll hold on to that. A right, on the other hand, I'm going to want to initialize with a B. Type B. Oh yeah, so notably, if I like mix up my A's and my B's, it says rights have to hold a B, but I said that B was a type A. I apologize for variables. I don't have a better name for them. Okay. And the idea here is that rather than constructing directly, I tend to write some helper functions. Last, I'm going to ask you to take on page, and then we'll start understanding these a bit more. So left is a function that takes a value and sticks it in the left. Right, a similar function that takes a B and sticks it in the right. These are just shorthands because I'm lazy about typing. It's not entirely simple. And the goal here is that I'm going to update each of these functions to, instead of returning whatever it's currently returning, to return either a string representing an or a whole data that it's returning, right? And instead of this for returning a string always, I'm going to have it return either a string representing error or a string representing value. The idea here was that a user, like I'll get a response back from prompt, but that response might be empty. And if it's empty, I want to error, right? So if response length is 0, then I want error. But I'm trying not to throw in types. I'm trying to be specific about my return types and not have things that aren't expressed in my types. What I want to do here is I want to return a left that says no.
So, good question.
No. Okay.
I think the Spanish syntax is greater, this triple equals and the greater signs, are they TypeScript syntax or?
Oh, okay. So two different things there. So the questions were on syntax. So the greater than signs are TypeScript syntax.
Okay.
So these are for generic types. Either is kind of a type constructor, it lets you build lots of different types.
Scroll back to the definition of item. Okay, go ahead.
Yeah. So this is saying like you can have like either a string or an integer. You can have either an error type or a user type, right? You can have lots of different kinds of users. They all have a similar structure. The structure is an either is either the left thing on the left or the right thing on the right. And those ABDs can be anything. So the brackets there, when you see that, are expressing the generic types in TypeScript.
Really, it says like type either AB. So but either with an A and B there is not actually a type. It's not a type until you plug some other types in for the A and B.
They're types.
So then you have either string, then A equals string, B equals string, and now you have a type once you plug actual concrete types in there. Because the A and B in that definition are like abstract. They do whatever you want.
Type variables, I think is a more thing.
Why we have at the top line here either type A or type B, and then left A, B, and right A, B. Why is it why is that not written either A comma B equals just A vertical bar B? I don't see the point of the whole left and right.
Yeah.
Right. Why can't we just mean that looks more like what we're doing?
That is usually that's absolutely the thing that you would like to write if our computer were smart enough. Yeah, so a couple things there.
But am I right? This captures the idea
Absolutely.
in a way that's kind of more
Absolutely.
human friendly.
Yeah. Yes. Thank you. No, absolutely. Like that is the intuition. That's what we want. Part of the problem there is like sometimes, like in this case, we are using a string to represent both the error type and the response type, and so like just saying string or string is not enough for us to really know whether it's an error kind of string or a non-error kind of string. So we need some kind of wrapper to distinguish between the two. And like it bothers me that I can't write this because that is what I want. Like, that's the intention. But that wasn't TypeScript for me. If someone's better at TypeScript than I am, that can help me work through why, I would understand that better myself. But yeah, like that is absolutely the motivation. Some of this is just easy.
So the way I want to write it is the right way to do it, but it doesn't work. So
Well,
Yeah,
it's not only, it's not just a type checker though, it's like what he said about if you have string, bar, string.
I'm just trying to think about what that would mean, so I'm still processing that. So like, if you try and pick out the arguments by type, you have that problem, but if you were like sequence numbers, for example, you wouldn't have that. And so it just, the whole, I'm a little, we have JavaScript, now we have TypeScript, which is kind of a whole other layer. And I don't know that much about either one of them, so it's like I'm ripple confused here, but that's okay.
But like,
C++, you can.
Well, actually, I'm a C++ programmer, so I take this, I translate it into C++,
Yeah.
and then it makes sense to me. In C++, well, we would just call this a variable,
Yeah.
and we would be done. And the whole issue of picking out which parameter is done more in the way that I just described. You
So-
pick it out by the name.
so I think there is still some important like metadata that we can capture somehow, right? Like if we're expressing both our error as a string and are allowing response to be a string, then like if it's for our function and we didn't tag different code paths somehow, then there would be no way to distinguish between the error no given and a user the type and O space, right? Like we have to enrich those somehow. I will grant this more ceremony than I wish were necessary. But it seems to be what is currently necessary to my
Since you brought it up here, why have we defined our pair of types as two strings? Why not just one and an error code and then the string comment. So then we wouldn't have this issue of trying to distinguish two things that are different but have been expressed in terms of the same type.
This is a weird question, but what if the happy path returned an error code? Then you lose the ability to distinguish still.
But the happy path would never return an error code.
Why? Maybe you want a function that simulates an error.
Well,
So like, I think the reason I think we're kind of off with the point here. So like I'm happy, but let's try to get through happy path, and then we can. Again, I will grant that this is more ceremony than is necessary to express the central idea, and I think the right motivation here is to think of it as A or B. That's really kind of what we're trying to capture. But okay, so given machinery that's necessary, we are trying to return this either type of a string or a string. Does it make sense why this is now the required return, right? Like if there's an error, we capture that by saying it's a left node in given. And if there's a real value response, we capture that by saying it's a right response. Cool. So let's see, we kind of have two ways to go here. We can and we will update all of these functions to, instead of returning whatever they're currently returning, to return an either type similarly. But why? What's that going to buy us? What does it help once program returns an either, find either, returns an either? Where are we going to go from there? That's a big question. Trying to make it more precise.
That's a common objection to the style that you're using is now the caller of these functions has to like wrap and unwrap and like check every single like value to see if it's a left or a right. Is that where you're going with that?
That's fair. Yeah, I think so. I think the whole problem is, assuming we did this, right? Assuming we went through all of the work of updating all of our functions to return either types. So that instead of having a string, instead of having a user, we have either a string or a string, okay, either an arrow or a user, either an arrow or a string, and so on. For us, our goal here is for us to fit this pipeline together. And so what we need is some consistent way to apply these functions to the either types. And remember, what is as I apply this pipeline, I want, like, if something error to begin with, I want to stop processing, right? Like, if I try to feed it through a function, don't bother, skip. But if I do have a value, if I have a right, I do want to apply functions. Well, what I need is some consistent way to handle left and right types to give them the same signature. And I want to be able to apply, like, I want to be able to apply these functions one after the other. I want to be able to apply this first function that takes a string and returns an either arrow or string to a function that expects just a string. Right? So yeah.
Yeah, can you just define the parameter as the either type?
I can. Yeah, that's totally reasonable, right? So like, I can have like any identity that's an either string or string. And in every single function have check if it's a left, and if it's a left, return a right. I totally can do that. That'll work. I don't want to have to remember. I'd like something more sophisticated. And what I'd like is for my either type to handle that, right? I want both of these to implement a common interface where I can say, here's a function, do your thing, and the left and the right both know what to do, right? I want some kind of polymorphism. So I'm going to do that by defining a chain function. I think this is the last most brain-bending bit downhill from here. But remember, the goal is I want to be able to take an either and feed it through a function like this that doesn't expect an either, right? So I want to be able to take my right value and feed it through a function f. Like this is a right, yeah, and feed it through a function not expecting an either b, but instead a function expecting a b. Sorry. So what I want, let me rewrite it and then we'll try to disentangle a little bit.
AC?
There, yes, thank you. All right. I have a right AB, and a function that can take the b, which is a flat, unwrapped b, and I need to end up, I can't end up with a c in general, because something could have failed. But I want to be able to end up with at least either that single failure captured, or the function applied to the value that I do have. If you buy that, I think this is the right type. And if you buy that, the implementation for write is actually really easy. You do the only thing that can possibly work. Namely, you have your this.value, which is a b. You have a function that knows how to take b's and gives you back either a or c. And in that case, that's what you need. Oh, my type checker is not. Yeah. So C, and like C is a variable I don't know here. Here's the syntax for saying I need a variable C. Now, and again, the goal of this is to have a consistent chain function that both sides of the ether can use. Where the notion is, if I have a right value, apply the function. But if I have a left value, don't bother applying the function. There's nothing to do. Instead, just return here.
A, C.
Oh. It's not knowing the p-value. Sorry, TypeScript nonsense, please ignore.
Could you do this in just JavaScript?
You absolutely could. Yeah. So I think like the advantages of doing in TypeScript are, one, in the real world, someone else writes the monad library for you, and you don't have to worry about any of this. And then when you go and write your code, it will yell at you if you mess something up. This is the hard part. This is the part where you write down one time and forget about. Sorry. Mostly it's helpful. So again, like if that felt like overwhelming or not helpful, like assume it is for you and observe the developer experience from here on out.
You need to chain on the either class or the either type?
You don't need chain on the either type because TypeScript knows that there is a chain implemented with consistent type on both. Yeah.
That line knows that? Okay.
Which is a neat part of why you need both types here versus know that they are on consistent type. So, like there are other ways to model this, but yeah, for now I just have a left and right. Like if you have an either, you just know it's left or right, but left and right both have a chain method at the same time. So whatever you have, you can chain on. If you're chaining on a left, it doesn't do anything. The function just returns the value you had here. If you have a right, it actually does apply the function. That's the idea. Okay, so anyways, that all given, let's finish converting these functions, and then let's use that chain method to actually chain them together. Find user. My goal here is to, instead of returning a user or undefined, I don't just want to give back no user all too long. Right? I want to return either string or a user. For me to do that, now when I return stuff, I have to appropriately tag what type of value it is, right? Like if I have a user, cool, I have a right, that's a success. In this path, there's a failure. And my requirement is I have to give that string error message here, right? I have to write it in appropriate error. I think the best I can do is like could not find user with identity. But the compiler forced me to handle all the error checking in the flow. Right? That I believe is the compelling part about TypeScript here. Generate recent token, like I said, we probably should worry about state token failing. I'm not going to. I think one thing I didn't worry about at all here, but probably should. This deliver reset token talks like an external service that could be down, right? Like I can throw an error. So let's say deliver reset token also returns either string or envelope. And let's do that by saying try to deliver email. And if it failed, catch the error. And my thought is that, although again the compiler will yell at me and say you have to indicate this was a write. and this was it left. Okay, but like once you have your pieces all individually instrumented consistently, now let's look at what we can do here. So worth noting that identity is not an identity; it's like any identity, right? It's either a string or a string. And I want to get a user. Well, I can't get a user because I could have an error. What I really want is I want an e user, which is an either string or user. Given that I have this either identity, right? Could be left, could be right, but it doesn't matter. Both my left and right know how to consistently handle chaining a function of the right shape. Sorry, e identity. Right, so that type checks. I don't have to worry about there not being a user. I have an e user, which is either type. So the next bit, like const token. Well, I don't always have a token. I might have an error. So I really want to end up with either a string or a token. And I can get that by taking my e user and binding. I guess I would like to chaining the generate reset token. That doesn't quite type check. Right, it's saying I expected a function that returned an either, but you gave me a function that would just return an honest token. You could change the definition, but I'll point out again and kind of patch that up here. There are other ways to handle that, which we might look at in a moment. But for now, that's one way to take your kind of flat baseline value and lift it up to an either type. And finally, finally, I have my either error or token. And so I want to return the result of taking that either error or token and chaining that through deliver reset token. And when I do that, I don't have an envelope undefined. I have an either string or envelope. Okay, so that gets it to type check. I don't think it gets terribly illuminated. There's a lot of boilerplate here, but the structure is consistent, right? I'm gonna erase these type animations so we can kind of focus on the code. And I'll point out that you would never write this in the real world, right? Like you wouldn't write variable in assignment, you would chain them, right? You would write prompt for user dot chain find user dot chain this function that you have to which is a little gross dot chain deliver reset token, right? And so those are equivalent. But now we're finally back to kind of where we want to end up, right? We have the sequence of operations. Now the structure of the thing they return is sophisticated enough to know that it can fail, but it is that structure that has an appropriate chain method that knows how to handle failures. So I don't have to repeat that logic in every method, as long as I just return values of the right type. Now you may say to yourself, like, I hate that I had to like annotate this right here. Like, this generate reset token like doesn't have anything to do with error, it doesn't error at all. I don't have to worry about this nonsense. And you're totally fair to say that. It is pretty common to package up other methods in your object, so you could write something like this. All right, that would be my goal. I can do that. I'm just going to add these. Right, so if you have a function that just returns a C, not an either C, this would be the right thing. I'll add, oh, sorry, what? I'll Slack or I'll send out this code for you to stew over these bits if you are interested.
An extra parenthesis on your left case.
Thank you. But like again, you would use a library that provided these for you. With that given, you can map instead of chain. Like this just says, all right, the next step in my pipeline doesn't error. I'm not worried about it. So those are equivalent. One thing that I find particularly compelling is that we can even, right, like the thing that's changed is now these functions all return a consistent either type. And we can kind of reconstruct our pipeline operator. It's a little bit different because, like, remember, our old pipeline operator took a list of functions and then a single value and did this. Right, kind of applied them one at a time. I can do something very similar, where instead of thinking of these as being functions that return, values that plug up one after another, I can think of them as chaining, as like pipelining this chain operation. And if I do that, I won't call it pipe, I won't call it pipe K for reasons. But if I do that, then I can reconstruct my original function by doing this. Yeah. Right. Remember, the only thing that kept these from composing is that each step along the way could fail. If you build up a pipeline operator that is smart about how to handle that failure, then there's no reason you can't just compose them one after the other like you're used to, right? Like, I think finally, like, this to me starts to feel like the real benefit of this approach is we've shifted the error handling away in a way that's guaranteed consistent, like guaranteed type check, and we don't have to worry about it. And what our business logic ends up being expressed as really high level, like these are my intentions, this is how I think about Calvin. I can finally express it checking in that lane.
And remove it at the site of the actual error.
Yeah.
Instead of checking it before you move on.
Right. So those are all good ones. Yeah, so I think like that's kind of the process that I feel like we have to handle this. Like we have to handle the errors, whatever extra bits. But at least we can kind of be principled about where that handling goes.
Are you going to say what this has to do with category theory?
I absolutely will. We're going back to the slides. Anybody want to look at some code stuff before we switch gears back to the slides?
Okay. Well, the first question is, how does if some error occurs earlier in the process, how is the operation short circuit? In other words, typically we would say, if the user's open, if the user function had a problem, just bail right here. But I don't really see any mechanism for doing that here.
So the relevant bits of short circuiting are in our pipeline operator or with more explicit form, we take one value to the next by doing this chain method. And the chain method is defined differently on the left type. So that if you have a left type that has a value, remember that represents an error of that type, and you try to chain some operation, it doesn't do anything different. It just returns that same left value. So the relevant thing is that the left chain does nothing. So it just kind of feeds that value.
So it doesn't really short circuit. It just turns by convention the left chain. We don't do it.
Turns it back on.
It totally short circuits. Like it's capped in F.
Well, but the subsequent operations have to exclude and explicitly exclude that failure path.
No, they don't specifically exclude it. The next operation will see that it has a left, and so it will ignore its callback, and so on and so forth.
Well, see, okay, I would say that's not short circuiting, but then of course opinion could differ. But I think the other question is.
So I think it's relevant that like the generate reset token has no mention of either, no error handling specifically whatsoever, and will never be called if something before this lefted, right? Which I think is relevant.
So if one of the operation failures, none of the subsequent operations will ever be called.
The machinery of chaining stuff together will be called, but the functions that handle the subsequent steps now.
And I'm also concerned about, let's hope that we make a chain here, we have 4 members in the chain. And it seems like as we go farther down the chain, the universe of return types gets constantly larger. And because it would The second one has to contemplate the possibility the first one fails. But then we're passing that on to the next one, and it would have to contemplate the possibility that the first one failed. What am I missing here?
Well, there's not much to contemplate. Just like if you had a failure, you return it, right? Like our types aren't expanding because it's always in either string, which is our error type. And if a later computation got an error in the form of string, it just passes that same string forward.
Yeah, but go back to the definition of chain for left again. So I understand your intuition here. It seems like we should have an either, an either, an either, an either, right? It should just like
Sort of, yeah.
Either. But when you look at the definition of chain for the left class, you see it doesn't return a nested either. It takes the error value and packages one layer around it. So chain is always returning exactly one layer of this abstraction. So it's never gonna like nest like we kind of were.
I mean, I have to think about it more, but I think you captured my, how should I say, my queasiness.
Yeah, you know, I think this is like I know all the way down, right? Like 4 layers. But that's, you know, the chain method is constructed in such a way that it only ever goes back 1 layer.
Okay. Oliver?
Yeah, that's my question.
It happens a lot.
Okay, yeah, I guess to clarify ages. So instead of passing down, like instead of the function getting called, it just instantiates another left object.
Yeah.
Every time it varies. Essentially a bunch of objects instead of calling the function.
Yeah, really, you probably should just pass forward the same value and not do up a new one each time. But that's like, again, I'm not concerned about performance here. I'm worried about expressiveness for the moment.
So envelope, does it have to be a string and token? Those types?
No, they're types that are defined elsewhere. Again, I'll flag out these code. Like here's the backend for that stuff. There's some custom types. It's just not really relevant for the example. Okay, cool. I'm happy to look over any of that for as long as anyone wants to. But let's kind of try to take us back. Again, remember the motivation. The motivation is we have these operations. We'd like to pipeline them together, but they don't actually fit up because we acknowledge that things could fail along the way. So instead of thinking of them as these like kind of close enough, but like types that lied to us, we expanded the types to look something like this, right? Each step along the way, instead of returning the value, has the possibility of failure, encapsulated by returning an either string for the error or the actual type. Once that's done, we can wire them together by chaining. Sorry, I used bind here, not chain. Bind is a common word for that method. It's just the chain that we talked about. And to make that work, we defined an either type. That's just wrong. I'm sorry. I'll fix that. An either type that packaged up the left of one type or right of another with appropriate definition of bind and made that work. So that's the motivation. Yeah.
It's a happy mistake. I know bind, but I didn't know chain.
Oh, yeah. Same thing?
I mean, it depends on your library, right?
Yeah.
The crucial thing is the shape. So the shape of chain is that it takes like an A and it gives you an either. It takes a thing and then gives you an either. So it's like a fancy function. It's not just taking an A to a B. It's taking an A to an either something B. Like it's a fancy function, I guess.
Yeah, like there's a whole list of examples that look kind of like this, right? Like we could have structured this differently by saying like, instead of things erroring by getting back to string that said what happened, it's just like maybe we just allow for things to be nil along the way. And we want to do a very similar thing, right? Like we want to be able to pipeline these. We can't quite, each one doesn't take undefined, but it's kind of obvious what to do with one undefined and just kind of fail out of it, right? So like exercise 3 here. You do the same thing. You'll want to do something that looks like defining a maybe type that's either a value or nothing. If you have the value, cool, you apply the function to the value. If you don't have the value, well, you don't do anything. You have nil still, undefined still, right? But like it's structurally the same thing. And if you had that, you would chain them together, right? If you had these maybe types, your pipeline code operating, like wiring these together, would look the same.
Except that generate reset token needs to be bind here because
Oh, yeah, sorry. Good call.
User domain reset. So
Thank you.
rather
I'll
than
fix
use-
these slides before sharing them out. I usually keep it over more. Was pressed for time. Another super important one for JavaScript people that we run into all of the time is a lot of times we like to think of our functions as plugging up nicely, but we don't because they're asynchronous, right? It takes some time to return a value, and so you can't just wire them one after the other. You can model this in the very same way, having an async thing, as long as you define things appropriately. Async is just a promise, right? And the way you find a value of a promise is that. It's you wait for the value, and then you apply a function once you have a value to apply it to. It's the same intuition. And if you wanted to build a pipeline of promises, you could do so with exactly the same structure, right? So what do these all have in common? Each of the examples has a type level transformation that I'm going to call M, right? That takes kind of the base type and extends it somehow. A way of kind of lifting a base value, so a way of lifting a function, right? If you have this like enriched thing, and you have a function that would take a non-enriched thing up to an enriched thing. The words here are terrible, I'm sorry. But like if you have a function of that shape, you have a way of binding it together, right? Like even though they don't quite compose, they're close enough to composing that you can do it anyway. And a way of lifting a base level value into an enriched one, right? Like if you have an A, you can turn that into like an A. If you have a promise, you can turn a promise that just immediately resolves. Incidentally, and because all of those things exist, we can build pipelines, we can kind of chain things, like right, we get functions that are composable enough. Monads. You may have heard, here's the definition of monad. Monad is a functor M which transforms the type A into a new type M of A, associated with two functions, unit from A to M of A, and bind that takes an M of A function from A to M of B, and returns an M of B, subject to some rules. I'm not going to write the rules. The things you would expect if you thought enough about it to expect anything.
I think the rules can summarize to say that type has to work in the way you expect it to work.
Yeah. They really summarize to say that that bind is a compositional operator. That these kind of cross functions form a category that can be composed.
So are you saying that it's basically a function that's going to behave well if you play it with a bunch of other ones?
I'm saying a monad is anything that you combine in the way that you combine stuff in our examples.
So if you think about it like thematically, we talk about categories, and categories have like objects and functions between the objects. And so we have our ordinary JavaScript types, which JavaScript values have a type. If you don't believe me, then type anything into JavaScript, we'll say type error, right? Okay, so JavaScript values have types, and so their functions go between types. And you have normal function composition, you just put two functions end to end. A monad is where you change the definition of composition. So when we wrote chain, we changed the definition of composition so that they don't have to line up exactly, as long as if they have this like kind of similar shape, this shape A to MB, you can't plug an MA into that function. You'd be like, if I have like a decorated A, you can't plug that into that function. That function expects an ordinary A.
You can't plug a promise returning an integer into a function that requires an integer. You have to wait for the promise to resolve.
So what we can do is we can, well, let's change the definition of composition in a consistent way. And that's what a monad is. A monad is, okay, I'm going to change the definition of composition for this part of my program. What part of the program? The part of your program in between piping, basically. Like, you pipe all the things together. Conceptually, these are like functions, but they're kind of like buffed functions. And so, well, I have a way to compose them, even though they don't compose in the usual way. I have a way to compose them.
Isn't this kind of what I was referring to when I recall or suggested making a shim type, which transforms the type we got into the type we need? And so this whole monad thing is kind of like a joke, but I would say it's just a wrapper that composes two types into one. And
in a consistent way.
What's the word? Regular way. And that's kind of the end of it. We use it in order to make the type that is produced compatible with the type that's required.
Yeah. So I know monad is a horrible word. I'm so sorry for it. But like you've seen them, you've used them. The example we looked at today, like maybe it's an extension of computation that allows for the possibility that functions might fail to return a value instead of return undefined. Either is an extension of computation that encapsulates like a value or an error type. List is multi-value computation. If you think back to our example where we started coding, we looked at you could kind of smash lists together to get multi-value computation. Think of that as like non-deterministic computation. Async, right? Promises are a monad. There are others I'm going to talk about, but if you have languages about not doing anything with side effects, you can use monads to follow side effects. I won't say much more than that because we're structured. But like the important thing is a monad is just a way of extending functions composably, right? It's the structure that you need to be able to compose stuff together. I'm not going to do state because I think we've got enough. State is an interesting example if you want to work through it at some point in time. Takeaways. So like let me step back here for just a second. I believe that a shared language for describing problems is really crucial for shared understanding, right? Like I work in a big giant code base with a ton of people, and I need to be able to land somewhere and understand the intent of the person that wrote stuff. So on the one hand, it's nice to have patterns that can kind of separate out the developer's intent from the actual implementation. Also, I think it's important that we all kind of have a shared understanding of what the pieces that we use over and over again are. And like it or not, mathematicians got to composition long before programmers did, and category free theory is the lingua franca of composition. So like it really is worth your time to learn these terms. I know they are formidable. I know they're not what we would write if we started from scratch today. They were made up by academics a long time ago. But like as daunting as the language is, they're actually relatively straightforward concepts that really are quite useful and are honestly ubiquitous. Like once you know what shape you're looking for, you see it all over the place. And understanding the structure of that shape really helps you frame the problem appropriately in your head. I hope to have convinced you that you could have invented the monad. Maybe. Like the maybe monad, maybe. Bad joke, sorry. Thank you. I would encourage you to learn Haskell. I think a lot of the stuff that I learned here, like I do have some math background, but like I think a lot of this was made precise by poking around with Haskell. The nice thing is the compiler there is snickety enough to force you to get the details right. You can program and understand this to some extent, which is frustrating at the start for sure. But I think you feel like you've learned a lot for it once you get there. So A+ would recommend. I have a bunch of links. I will share all of this on the meetup, share pics on the slides, and have a ton of work. So that might be in a couple days, but they're coming. Would recommend any of these. Also, like feel free to reach out to me. Always have a chat about stuff. That's it for me. Count down time. That was long.
We have 12 minutes.
Rad. Okay. Awesome. So yeah, questions.
Yeah. So either maybe are those like given monads in TypeScript already? Is
So
it for you or?
yeah, no. TypeScript does not have any built-in notion of monads. I get like I don't do a ton of work in JavaScript. My personal projects are in like Reason or Haskell sorts of things usually, and at work it's kind of pure JS. So if anyone is more familiar with these, feel free to correct me. My understanding is there are a handful of fairly popular functional programming languages on the JavaScript side. Ramble is pretty good for functional composition, although I don't know if it has any kind of monad notion built in. I did look, there are a handful of, it seems, reasonably popular TypeScript monad libraries, but I don't know about anyone in particular to speak to them.
Follow-up question, like I noticed in these classes for that brief on it's like the different classes interface.
Difference between classes and interfaces in TypeScript. The class here it's a JavaScript class. The reason that I want these to be classes here was just I wanted to be able to have a chain method that I could reliably call. There are other ways to model these, like tag unions. I don't know. I honestly don't know the infrastructure of some of the other libraries and if this is necessarily the way they do it. An interface in TypeScript I have not used here, but an interface would be like, so you could write like an interface for like a monad for a has to have a chain function that takes a b.
I don't think you could do that without high prime types.
Yeah. Oh, yeah. Yes, correct.
So like I said, interface, you can't use that though. Just comes the difference.
Correct. Yeah, an interface is just like a behavioral specification. So like, any this is not what I'm gonna. What's a better example? Right. An enumerable is a thing that has an each method that takes the function.
You can define either as an interface with the church encoding, like with takes two callbacks, or you do a plat, one that expects an A, one that expects a B. I don't know if you want to do that.
No, I think I want to do that.
Yeah.
That is true.
But it's in the, yeah, I think you pick classes because they're kind of like, they should kind of be familiar with JavaScript people, right? Where interfaces are not so much be.
Yeah. No, can't. Okay. Like an interface just says like, things that are here in the interface have to have these collection of functions, these arguments, and values.
It doesn't define it, right?
It does not define it.
It's just a signature.
Right.
So I have like an operations question. Like you have a big team trying to figure out a problem, and so everybody's trying to figure out what are the pieces, and you're trying to get everybody to say no, you have to use monads and you have to use TypeScript, and it'll, have you done that at scale? Like have you done 30 people? Okay.
Not scaled. Again, like I work back and stuff. My day job. Like I have used these sort of things in my personal projects, and I have found them very nice. Obviously, there is a learning curve. I'm not gonna lie. But
one problem in front of you is so I'm constantly like tripping over problems I wrote or teenage wrote months ago, and like I got just a good promise and it's so clear, and then I come back and look at it, it makes no sense at all.
Yeah.
And so looking at this, I'm like, well, maybe like filter nodes will make more sense, and then maybe if filter node will make more sense across more.
Yeah.
And I'm just curious if it's just like
sure.
So the idea makes more sense. It seems to me like wildly.
yeah.
I don't know if it'll make more sense, but like, you know how like, regression, all these things that right? And that's not really written in the title. As long as your types are completely honest, which is something that James endeavored to do here. As long as your types are completely honest, then that function becomes a black box. You don't have to understand what's inside. You know you know what it expects and what it's going to get back, as long as the types are honest. Now, if the types are not honest, it's an implementation. So that's sort of make more sense later, but they're like later on, you know, you decrease the surface area that you have to pay attention to. But if the types are honest, the function becomes a black box.
I will say, I do work on a massive Ruby app at scale, and the only things that I have ever found that help that problem are you write lots of really small pieces that do what they say on the tin, and you make it as hard as possible to plug those pieces together along. In Ruby, that's often like packages that configure appropriate ways and like constructors and whatever. Like that. At the end of the day, that's it. And this, admittedly, shared language understanding is a very good approach to that. It encourages you to write different pieces that have well-defined types that do what they say on the tin, and gives you really principled ways for understanding how to plug them together in a very rigid, predictable way. I think Daniel has probably done more of this stuff at scale than me, so if there's anything else you wanted to add, feel free. But I think, like, learning curve aside, this feels like it ticks the boxes fairly cool.
Yeah, I just like to add, for that, you don't want to like try to figure out what the parameter is. The parameter is like some crazy object, different attributes. And inside is another object. You can be better. Oh, so this or reset object, and then next to it, maybe we're talking about user key. And then so you set like a function or how you want to reset user. So instead of running, we're trying to dive in to figure out what I'm actually getting with this multi-dimensional array with all these random attributes. Well, it tells you right there, hopefully, whoever awarded the type is good enough at working, and it should be a lot more obvious, easy to read.
The problem that people programming languages suffer from. People think up some great idea which will happen to them, and then they drop it in, and 6 months later, the next guy comes along and it's not at all obvious at all. And for whatever reason, it's just too hard to write down what you think the thing is supposed to do. It's just easier to just do it.
I will say two things. One, like, I think if you've done much like object-oriented stuff, you have probably committed to memory a large number of design patterns and stuff that start to look familiar to you. And that, like, hopefully one of the things that starts to illustrate is that in like your world, none of that's necessary for all just monads. Like, if you have this one composition, it covers so much of the space of ways you might need to plug stuff together that you get a lot of mileage out of relatively few abstractions, which seems compelling to me. I'll also mention like the just benefits of strong typing stuff in general. Quick plug. Procore is going to be hosting the Elm meetup. Like, we're finalizing the details like end of this month. So I would encourage you to check that out if you're interested in a like very strongly typed sort of approach. Somebody at NoRed years and years ago, like, they had been running Elm in production for 3 years and hadn't had one error the entire time, which is rather compelling. So yeah, like to Daniel's point, like if you have a very strong type system where your types cannot like you and every function does what it says, your compiler can prevent all of but like all of the writing. You can do the writing correctly. But oh, totally, yeah. Cool. Anything else? I think it's about time. Thanks for coming out and listening to another tutorial. I appreciate it. I will be happy to chat more if anyone is interested. I liked it. I will say, like, I mean, like I said, there have definitely been where I feel like something's easier to express than it.
Well, man,
sometimes,
yes.
Yeah.
He's a
when I've had to
letter
dig in and like write the hard scare types, I'm like, just
so he has
once the types are set and once they are expressed well, the experience of using it from there, like the refactor and the compilers stuff,
I mean, he looked like a Lazarillo, but
yeah, this is
so
so
wiry.
generally recommend, but it's not as painless. I feel like if you're like in the React ecosystem, like React stuff is fairly well typed. There's a lot of like good support where you just drop it in and like all of your React things you're using or whatever, like they just have types for you and you don't have to worry about it too much.
I just keep hearing that types.
but he is in
And now you did it.
He could read. If you find another one, I'm sure he would be enjoying it, right?
I think it's worth exploring.